All right, so I only have two more examples, and the last two are, I guess, a little bit more difficult than the first four examples. And let's take a look at this one, right? So you know that you have to condense, right? The first step is to condense into a single log. Okay, so you cannot just exponentiate by base e, right? Hopefully you get the picture as I've explained that multiple times in the previous two examples. All right, so, a simple condensation would just be, if I add the two logs, right, the power property tells me to multiply the argument, so it becomes x squared plus 2x. And on this step right here, right, you exponentiate both sides by base e. Okay, so whatever you do to the left, you do to the right. Okay, so you end up having this. All right, so this is all the log skills. From this line to this line, this is log skills or / concepts. All right, that's it in terms of logs. And now what I'm trying to do is solve for what x is, right? And so again, this is a quadratic equation. And so you just have to know how to solve a quadratic equation, right? You have to move, remember, e to the fourth, that's a number, right? E to the fourth, if you enter that on your calculator, approximately, this is going to be, e to the fourth is approximately 54.59, right? And so you have x squared plus 2x minus e to the fourth. So can I just write, 54.59, right? Because isn't that what the number is? Yeah, but remember, the problem asks us to find the exact solution, right? Find the exact solution. So you can't use, you cannot use 54.59. But I just want to show you e to the fourth is a number. And so I move it over, right? And now you use the quadratic formula, okay? You could use the quadratic formula, or you can solve by using completing the square. Okay, so I'm going to solve by CTS, right? Why is CTS easier? Because look at this number. This coefficient right here is a nice number. It's an even number. This number right here, this A value right here, right? The coefficient, A is equal to 1, right? So it's easier to complete the square. So what I'm going to do right now is simply move this e to the fourth to this side, right? And then complete the square, right? 2 divided by 2 is 1. 1 squared is 1. So whatever I do to the left, I do to the right. And now, right, this is x plus 1 quantity squared is equal to e to the fourth plus 1. Take the square root of both sides now. Now, when you use the square root, right, you have to write positive square root of e to the fourth plus 1. Or x plus 1 is equal to negative square root of e to the fourth plus 1, right? Okay, so you're going to get two answers. X is equal to negative 1, positive square root of e to the fourth plus 1. Or x is equal to negative 1 minus the square root of e to the fourth plus 1. Okay, so after all that work, right, am I done? No, remember, you have to check for extraneous solutions, right? So at this point, right, if you're not quite sure, which one of these actually satisfies the original equation, right? Remember, the way I check it, right, is I plug in my final x values and to see if it makes the argument negative, right? And so if you just do a rough estimate, right, e to the fourth we know is 54.59. Plus 1, that's 55 something, right? You take the square root of 55. It's going to be a positive number plus negative 1. So this one should check. Right? Now, when you do this, right, e to the fourth, we know is 54.59 plus 1, that's 55 something. The square root of 55, right, I mean, if you were to estimate, that's going to be a number between 7 and 8, right? So negative 1 minus 7 or 8, that's going to give you a negative value, right? And if it's negative, right, you can enter this on your calculator, okay, so you don't have to do it in your head. If it's negative and you try to plug it back in, right, that's going to make the domain negative, right? It's going to make the argument negative. So this cannot be negative, right? So this is actually a negative number, right? So let me, kind of explain what I'm talking about over here. If you plug in ln of -1 minus the square root of e to the 4 plus 1, right? Plus ln of x plus 2, ln of this thing, right? And what is it equal? It's supposed to equal 4. This is going to be a negative, right? And if you enter this on your calculator, this will also be a negative. So therefore, this is not going to be a solution, okay? So your final answer is just -1 square root of e to the 4 plus 1. If you want, you can also use, on this line right here, can also use the quadratic formula. But when you use the quadratic formula, right, you make sure you have to simplify all the way down to this, okay? So sometimes you'll recognize, right, you're going to have, square roots, you're going to have radicals. Make sure the answer is simplified and exact, right? Those are the directions I always write on my test, especially in your math analysis, right? You have to be able to practice those skills to a higher degree. All right, so last example, last but not least. So we're on example 6. Up until this point, every single problem that you've encountered had the same base. What if I switch up the base on you? Plus 3 log of, and by the way, this is a problem. I did not make this problem up. This problem is from an Algebra 2 textbook. So it's not even considered a pre-calc problem. Right? It's from Algebra 2 that was taught in the district a while back. Okay, or we used to use McDougall-Little Algebra 2, and I did not make up this problem. Okay, so in order for me to condense this, right? In order for me to condense, I have to have the same base, right? This base and this base are not the same right now, right? 9 does not equal 3. And so if I need the same base, I'm going to, let's say we'll call this way 1. I'm going to use base 3, okay? So make sure everything is in base 3. That's what I mean. And so if you want to change everything to base 3, this is already in base 3, right? The second term right here. How do I convert log base 9 of x into base 3? Remember the change of base formula? I kept verbally stating it out loud in class. It's the log of the argument divided by log of the base, right? Now, right now, this is base 10, but I wanted to change it to base 3. So you know what? Put a base 3 there. And that is going to be the key to this specific problem, right? You have to use the change of base formula so you can condense into a single log when everything's the same. Now, we're not done yet, right? Log base 3 of 9, you have to be able to evaluate. Log base 3 of 9, you can do that in your head. 3 raised to what power gives you 9? That's going to be 2, right? So if that's 2, write this as 1/2. Sorry, this should be a plus, a positive. Let me erase this here. This should be positive log base 3, right? This 3 right here goes on top as the exponent, as x cubed, is equal to 14. Okay, so hopefully you saw how I got from here to here. Log base 3 of 9 is 2, and so that just becomes 1/2. And now this 1/2 is going to go on top on this next line, right? To the 1/2 plus log base 3 of x cubed. Okay, now notice I have the same base and I'm adding 2 logs, right? You use your product rule for logs. X to the 1/2 times x to the 3, right? When I have the same base and I have different exponents, I add the exponents. This becomes log base 3. 1/2 plus 6/2 is x to the 7/2. All right, we're almost done. Now we can use our inverse property, right? Exponentiate both sides by base 3. So after all that work, you're almost done, right? 3 to the 14th is a big number, right? You have to know how to solve a rational equation. Sorry, not a rational equation. An equation with rational exponents. Exponentiate both sides by 2/7. Okay, 2/7. So that's going to cancel. This becomes a 1. This becomes a 2. You have 3 to the 4th, which is 81. Make sure this checks into the original. If you plug in 81, That's going to be positive. That's going to be positive. You're good to go. And in fact, you can check all your work. If you plug it back into the original, you should end up with 14. Okay, now as an exercise, right? Way 2, why don't you use base, instead of using base 3, why don't you convert everything, right, to base 9? So in other words, convert this guy to base 9, right? And you should get the same answer of x is equal to 1. Okay, so you can do that on your own and try it. If you have some difficulty, you're always welcome to ask me in class or during tutoring. And that will conclude our lesson